Greetings. Here I'll be presenting my work polymer-coated acoustic wave sensor for volatile organic compounds gas sensing application. The world is experiencing intense detriments from water, soil and especially air pollutants, a silent killer where it has caused around 7 million deaths. This is due to the overexposure of air pollutants resulting in stroke, cardiovascular diseases and respiratory-related diseases. Here are some sources of VOCs. Cigarette smoke contains harmful gases such as toluene, decomposition of paddy field and combustion of charcoal emits methane while fuel-burning appliances releases formaldehyde. This has brought the attention to the development of acoustic wave sensor-based detection method. It is a mass-sensitive sensor which transduces the energy from the change in mass on the sensor resulting in frequency shift. The selection and design of the sensing material employed in the sensor platform are key points with regard to sensor performance. Recent studies are directed more towards the use of chitosan, a sensing layer in which extracted chitin from shells undergo deacetylation process to form it. Chitosan owns advantages in terms of biodegradability, low toxicity, high permeability and modifications. The aim of this work is to investigate various types and deposition method of sensing layer for acoustic wave sensor, to synthesize and characterize the polymer sensing layer capable in sensing VOCs. Lastly, to measure and evaluate the performance of the sensor. The work progressed with chitosan dissolution, chitosan solution deposition onto QCM electrode, and characterization work and frequency measurements. So let's move on to the characterization and experimental results. XRD analysis gives strongest peak at angle 20 emphasizing chitosan crystal form. The peak is attributed to the hydrogen bonds associated with hydroxyl and amino groups. The broad width of the peak suggests that chitosan is amorphous and semi-crystalline. FTIR determines samples composition through the IR absorbance. The result confirmed chitosan composition based on the chemical bonds present. Through the FESEM images captured, the surface of the film contains clusters of undissolved powder resulting in rough surface and uneven thickness. The sensing principle involves sorption of analyte molecules onto the surface of the QCM electrode. Thus, change in mass on the electrode is translated into frequency shift. Vector network analyzer and QCM setup is as illustrated. The initial resonance frequency for bare QCM was at 10 MHz. Chitosan deposition has led to a shift in frequency due to mass change on the electrode. Further frequency shift is obtained as the analyte gas molecules are adsorbed onto the chitosan layer. Chitosan on QCM sensor is potentially applicable for the use of breath analysis, medical diagnosis and environmental air quality control. According to the work, chitosan has the potential to be used as a sensing layer of acoustic wave sensor for VOCs detection. Thanks for watching.